Today on Capechi's Corner, we're going to look at geometric sequences and series. Now, we've talked about arithmetic sequence and series, so now it's time for geometric. Now, remember, geometric, we're going to multiply. So we have our common ratio. What are we multiplying every term by to get the next term? Okay, so here's a little formula, an equation we're going to use involving geometric sequence. The AN, if you remember, stands for the last term. A1 is the first term of the sequence. R is going to be the ratio, what are you going to multiply by, and N is the number of terms. Number one, it says write an equation. So write an equation for the nth term for the following sequence. So we want a general equation. Okay, so we can pull out what we know. Our A sub 1, right, our first term is 0.5. And we realize that our ratio is 4. We're multiplying 4 by every term to get the next term. Okay, so our general equation is going to be A sub n is equal to 0.5, R, which is 4, and then we're going to have n minus 1. And that's the equation that we would use for this scenario. Okay, and the next one, it says find the 4 geometric means. Now remember, the geometric means are numbers that are found between the given values. Okay, so we have our equation, our A sub n, that's our last term. We know that's 512. We know our first term is 0.5. Now, we don't know our ratio. We don't know our common ratio there, but we do know that we have 6 terms total. So that's 6 minus 1, right? 2 given and the 4 between, which gives me 512 is equal to 0.5 times r to the 5th. Okay, so in order to find the values, we need to know our common ratio. So we need to solve for r. So I'm going to divide both sides by 0.5. And I have 1024, 1024 is equal to r to the 5th. Take the 5th root of both, and r is equal to 4. Okay, so from here, we're going to use this for our value. So 0.5 times 4 gives me 2. And then I get 8. And then I get 32. And then I get 128. Now, again, the nice thing about this, and we talked about this with arithmetic as well, is I can check to see if I get 128 times 4, I do get 512. So I know that I did the ratio correctly. All right, let's look at number 3. Find the 3 geometric means between 2 and 1,250. So the same idea, right? So I have 1250 is equal, my first term is 2. My ratio is what I'm trying to find. And in this time I have 5 terms, so 5 minus 1. So I have 1250 is equal to 2r to the 4th. Divide both sides by 2. And I have 625 is equal to r to the 4th. Now, this one's slightly different than the previous one. Okay, so I'm going to take the square root of both sides. I'm going to take the 4th root of both sides. And I'm left with r is equal to plus or minus 5. Now, we definitely need that plus or minus because we have an even power there, right? When we did the previous example, we took the 5th root, which is an odd power. So there's only going to be one value. But when we take an even root, we're going to have a plus or minus. So in this case, we're going to have 2 sets of values. So I could have 2, and let's say I start with r is equal to positive 5. 2 times 5 is 10, and then I get 50, and then I get 250, and then my last term is 1,250, which works out. Now this time, what happens if r is equal to negative 5, right? I would still start with 2. This time I get negative 10, 50, negative 250, and I would still have 1,250 as my final value there. Let me fix that too. It doesn't look very good. Okay, so in this case, you would have to use both. You would have to show both sets of numbers, both sequences there. Okay, all right, that's dealing with the sequence. The sequence is numbers in order, right? Now we're going to talk to the series, which talks about the sum. Okay, it talks about the sum. Now, we have a formula. This is the sum, the series formula when we're dealing with sum. They really are exactly the same, except for the fact that I took this numerator and basically factored out an a sub 1 to get those other values. So either one's okay, whatever you're comfortable with. Again, that a sub 1's the first value, and then we know we have our r to the n. R is the ratio, n is the number of terms. All right, so let's take a look at what we have in this first example. Find the sum given the following information. Okay, so I need to find the sum. My first term is 240 minus 240. My ratio is 3/4. The number of terms I want to add there is 7, all over 1 minus 3/4. Okay, now again, you're definitely going to use your calculator on this one. So the easiest thing I think to start with is I know this right here, that's going to give me 1/4. Okay, so I'd use my calculator. I would figure out what the numerator is and then divide that by 1/4, or you can even divide it by 0.25. And my final answer is 831.855. That's the sum. Okay, let's try one more problem for today. Again, different notation. We talked about the sigma notation in our previous lessons. Okay, so we have a couple things. This k is equal to 3. That's my first term, right? That's my first term. Value for k, and this is my last term, my value for k. And this right here is going to be my expression that I'm using. Okay, that base exponent there is always going to be your r value. Okay, so when looking in that, I know that my r value is 2. Now, the number of terms, if you remember from the last lesson, we went 10 minus 3, right? The last term minus the lowest, and then we're going to add 1. Okay, so that gives us 8. That is equal to n. All right, so let's see what we have. So my a sub 1, I need to find out what that is first. So a sub 1 is equal to 4 times 2, right? I'm using this expression here. And then my k is 3, right? Because we're starting with my 3 here. 3 minus 1. So that gives me 4 times 2 to the second. So my a sub 1 value is equal to 16. So I have my r, I have my a sub 1, and I have my n. Okay, looks like we're ready to go. So I have S sub n is equal to 16 minus 16 times, my ratio there is 2, raise that to the 8th power, all over 1 minus 2. So again, I'll put that in my calculator, and my sum is 4,080. Okay, thanks so much for stopping by today. You have a great day.